Thermal stresses. Whenever there is some increase or decrease in the temperature of the body, it causes the body to expand or contract. If that expansion or contraction is prevented, then the body is subjected to thermal stresses. L alpha T is the free expansion or contraction, where L is the length of the body and alpha is the coefficient of thermal expansion and T is the temperature difference. If the body of length 1 meter having thermal expansion coefficient 1.4 into 10 to the power of minus 8 per degree centigrade, and T is the temperature difference. That means it has raised the temperature from 20 degrees to 100 degrees centigrade. That means there is a change in temperature of 80 degrees. So that 80 degrees centigrade into the alpha for the material and the length of the material will give us the free expansion if it is heated. If it is cooled, then we call it as free contraction. If the ends are rigidly fixed, then this free expansion or contraction is arrested. Then what is going to happen? That free expansion, which when prevented, will result in the strain. That strain will result in stress. So we are going to find out the strain in this manner is known as thermal stress. So the thermal stress upon the area will give us the force experienced by the body. If the body is experiencing some amount of thermal stress and having some cross sectional area, with this two, stress into area will give us the force experienced by the body. Next, the Poisson's ratio. We know that whenever a body is subjected to some axial force, uh, the member is having length L. If the force is tensile force, then there will be increment in the length. That increment in the length to the original length is known as a strain or the longitudinal strain. Poisson's ratio. It is the ratio of lateral strain to the linear strain or longitudinal strain. Generally, when a force P is applied on a body of cross sectional area with the diameter D and having length L, due to the application of the tensile force, the length L is going to increase by an amount delta L. So delta L by L is the linear or longitudinal strain. So this will result in the change in dimension in the other plane. So length is in the axial direction, perpendicular to that is the cross section. In the cross sectional plane, the dimensions should reduce. That change in dimension in the cross sectional plane to the original dimension in the cross sectional plane is known as the lateral strain. Poisson's ratio is the ratio of this lateral strain to the longitudinal strain. Generally, when length is going to increase, the cross-sectional dimensions, whether it is circular member, we call it as diameter, whether it is rectangular member, one is width and another is depth, they are going to reduce. That means the lateral strain and longitudinal strain both are opposite in the sign. So one is positive, the other one will be negative. The Poisson's ratio, if shown here in the table for different engineering materials, for steel it is around 0.25 to 0.33. For cast iron is also from 0.22 to 0.27, and the maximum value of the Poisson's ratio is for rubber. It is around 0.45 to 0.50. and the Poisson's ratio is 1 for the cork. That means cork doesn't have any uh, difference in change in dimension. That means there won't be lateral strain or longitudinal strain. It is not going to take any kind of strain. Next, volumetric strain. So whenever there are changes in the length as well as in the cross section, that means there is change in the volume of the member also. That change in volume to the original volume is known as volumetric strain. This volumetric strain can be found out from the biaxial or triaxial state of stress. So from the biaxial and triaxial state of stress, we will directly find out the volumetric strain when that is equal to delta V by V, where delta V is the change in volume, which can be found out by multiplying the original volume with the volumetric strain. This volumetric strain uh, for a member subjected to uniaxial state of stress, it is epsilon into within the brackets 1 minus 2 by m or 1 minus 2 mu, where epsilon is the linear or longitudinal strain, 1 by m is the Poisson's ratio. Next, the bulk modulus. Bulk modulus is the ratio of direct stress to volumetric strain. Direct stress means when the body is subjected to a pressure condition. That means a cylinder which is having combustion inside it, or a body submerged in a body of water body. So in both these cases, the pressure is exerted in all possible directions of the body. So that pressure is directly known as a stress acting on the member, and divided by the volumetric strain is the Poisson's ratio. Next, relations between the modulus, Young's modulus, and shear modulus. That is G is the rigidity modulus is equal to m into E by 2 into m plus 1, or if it is written in terms of Poisson's ratio, instead of writing 1 by m, if you write it as mu, so E by 2 into 1 plus mu. Relation between bulk modulus and Young's modulus, that is k is equal to E by 3 into 1 plus 1 minus 2 mu. Next, torsional shear stress. When a shaft or any member which is subjected to action of two equal and opposite couples, the member is said to be subjected to torsion. The stress that is set up by this torsion is known as torsional shear stress. So it increases with the distance from the axis of rotation. If you move away from the axis of rotation to the outermost surface, the torsional shear stress will be maximum. Next, bending stress. When a beam or structural member subjected to lateral forces, it is subjected to bending moment. The stresses developed due to the bending moment are called bending stresses, and the value of bending stress is 0 at the centroidal or neutral axis, and it is maximum at the outermost radius.